Today we are going to look into simplifying cube roots, and we will try to factor the numbers into perfect cubes and take the cube root of the perfect cubes. Let's start with a list of perfect cubes. 1 cubed is 1. 2 cubed is 8. That's 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is of course 729. And 10 cubed is 1000. We'll probably use the perfect cubes up to 5 in our examples in the class. For our steps, first we are going to factor the expression into perfect cubes. And as our next step, we are going to simplify the perfect cubes. Now let's see some examples together. Cube root of 125. 125 is a perfect cube. Cube root of perfect cube is going to be 5. A cube root and a perfect cube are inverse operations of each other, so they will undo each other. That's why we try to see or try to find perfect cubes. So when cube root undoes a perfect cube, we will just get the number itself. Cube root of 8, that's 2 times 2 times 2, and 8 is a perfect cube, that would be equal to 2. On the next one, we have 75. Let's try to see factors of 75. It would be 3 times 25, and 25 would be 5 times 5. So I can rewrite my expression as 3 cube root of 3 times 5 times 5. Neither of these factors are perfect cubes, nor they can create a perfect cube together. So it turns out that this number cannot be written in any other simpler way. So our final answer for this one is 3 cube root of 75. Sometimes we would need to deal with variables. Whenever we are working with variables, an x cube, a cube, and a variable to the third power would be a perfect cube. Likewise, x to the 6th power, x to the 9th power, and x to the 3 times nth power will always going to be perfect cubes. For our example, we're going to write 4x cube root of 4x cube root of x to the 6th power times x. We separate the x to the 7th power into x to the 6th power and x. Now we can take the cube root of x to the 6th power because it's a perfect cube. We will have 4x times x squared times cube root of x. The x squared came from taking the cube root of x to the 6th power. Finally, we can write 4x cubed cube root of x as our final answer. Here's your U-try. Try to find perfect cubes as factors in 24. When multiplying cube roots, we will multiply the numbers that are outside with the numbers that are outside, and numbers that are inside the cube root with the other numbers that are inside the cube root. For the first one, we would have cube root of 8, which is equal to 2. For the next one, we have variables to multiply. Here's my cube root of y negative y to the 7th power. When multiplying the exponents, I will keep the base same and add the exponents together. That's how we got y to the 7th power. Now I need to separate that into perfect cubes. We'll have cube root of negative y to the 6th power times y. I can take the cube root of y to the 6th power, that's going to be y squared, cube root of negative y left inside. Now, one thing with the cube root and the negatives is that just like when you had a negative number to the 3rd power, it becomes still a negative number. Let's say negative 5 to the 3rd power is same as negative of 5 to the 3rd power. Just like a negative can go outside of a parenthesis with an odd exponent, in this case, with the cube root, a negative can also be taken outside. That means when you have cube root of negative 1, that's equal to negative 1. So we will take the cube root of negative 1 in front of the y, and that will give us a negative of y squared cube root of y. Our goal is to simplify everything that's inside the cube root as much as possible, because cube root of negative 1 can also be simplified. That's why we would have to take the negative outside as well. Now, on the next one, we have 3 times 2 multiplied together, 6, outside with outside. Inside 5 times 50 is 150. We are going to try to find factors of 150, and somehow, hopefully, we will see some perfect cubes among those factors. 150 is 15 times 10. 15 can be separated into 5 times 3, and 10 can be separated into 5 times 2. So I can rewrite my expression as 6 cube root of 5 times 3 times 5 times 2. And none of these factors are perfect squares. Also, they cannot be combined or multiplied to create a perfect square either. So this question turns out to be something we cannot simplify, and our final answer is going to be 6 cube root of 150. Let's look at the next one. Has both number, negative, and variables to take care. Let's factor out everything first as much as possible to see if there are any perfect cubes. Here's my cube root of negative 2 times 8 times a cube times b to the 6th power times b squared. I separate the b to the 8th power into 2 factors where one of them is a perfect square. Each of the perfect squares can be simplified and can be taken outside of the cube root. So we will get 2 times a times b to the 2nd power cube root of negative 2 times b to the 2nd power. One more thing I need to take the cube root of is the negative in here from our negative cube root of negative 1 being equal to negative 1. I can write negative 2ab squared cube root of 2b squared as my final answer. Here's your U-try. First multiply, and then try to see perfect cubes. Simplify your perfect cubes. Don't forget to simplify the negative one as well. When adding and subtracting perfect cubes, we must have matching perfect cubes. On the first one, we have cube root of 2 and cube root of 4. Neither of these can be simplified further, nor they match, so we cannot combine them any further than they are. This would be our final answer for this question. On the second one, we have cube root of 3 here, and I can separate 24 into 8 and 3, so we can rewrite in there, separated into 8 and 3, I will have cube root of 8 times 3. 8 is a perfect cube, I can evaluate that, and we will write cube root of 3 plus 2 cube root of 3. 1 cube root of 3, 2 more cube root of 3's, it will create 3 cube root of 3 as our final answer. Let's look at the next one. This one has some variables. Let's try to simplify as much as we can first. Cube root of x plus cube root of x cubed times x squared. We separate the x to the 5th power into two factors where one is a perfect cube. Let's simplify that perfect cube portion. Cube root of x plus x cube root of x squared. In order for us to add cube roots together, they should have matching cube root parts. Just like adding variables, 2x plus 5x is equal to 7x. In this case, the cube roots parts do not match, so this will be our final answer. Let's look at the last one here. Take the cube root of -1, that would be negative of cube root of 2, plus 2 cube root of 2 times 8. I know 8 is a perfect cube. I will write negative cube root of 2 plus 2 times 2 cube root of 2. This 2 comes from the 8 that was inside. Next, I will do multiplication and simplify my expressions further. Cube root of 2 plus 4 cube root of 2. -1 cube root of 2, positive 4 cube root of 2, they add up to 3 cube root of 2. Here's your U-try. Try to match the insides of the cube roots so we can add them. That's pretty much it. In the class, we will look into each type with a little bit more detail.